Now we look at one of the possible strategies to be implemented by the medium access control sublayer. If we were to look at the overall resources which are available to a network, we could partition them or split them amongst the users. That is, we do the channel partitioning. In this module, we shall look at the basic idea, and then we'd look at the most widely used channel partitioning strategies such as time division multiplexing and the frequency division multiplexing. The references are H.O. Lee, Dimitri and Bersikas, and Quiroz and Ross. The basic idea is to understand the type of channel and divide it in some finite number of pieces. This could be in terms of time slots, in terms of frequency in an analog system. If you are using, let's say, core division multiple access kind of strategy, assigning unique codes to every user, and the space division multiple access, in which we reuse the resources provided they are spatially apart. In channel partitioning, what we are implying is each user is given a dedicated chunk of the resources. Time division multiplexing is the simplest of all and the most intuitive to understand. Here, what is shared is the time slots. Each user gets to have a constant or fixed length slot, and this slot comes after a certain round. So in a round robin fashion, each user gets to access the channel for a limited slot. If the user itself is not active, or if it does not have data to be sent, the slots go unutilized. Obviously, in strict circuit switched networks which are based on time division multiplexing, the resources could get wasted. Let's take an example here. Let's assume there are 6 stations in a local area network. Of these, 1, 3, and 4 are active, whereas 2, 5, 6 are idle. So the overall utilization of the network is going to be 50%. That is when we assume that the time slots which are being provisioned and the users which are active are fully utilizing these time slots, and their frames are exactly based on the complete duration of the time slots. But if the frames are only a fraction of the total time slot, it is going to determine the overall utilization of the TDM system. That is given by F is equal to summation for all j, alpha j and times xj, where alpha is actually the weight for the particular user which is active and the occupancy of the frame in that time slot. In this case, when we are expecting the frames to be exactly the same as the time slot itself, the efficiency is going down by 50% because half the stations are not active. It could go worse when the frames are smaller than the time slots. Another strategy for multiplexing is the frequency division multiplexing. Here the spectrum is divided into non-overlapping frequency bands. Each of these frequencies is assigned to every user. If we want to see how exactly frequency division multiplexing systems utilize the overall channel, we take a similar approach in which half the users are not using their frequencies and half are using their frequencies. Again, the overall utilization depends on the activity period, or we can say the duration of their transmission once they have been given a certain frequency band.